So this is the printer that I made in my spare time. I call it the Fabricore 3D printer for a combination of Fabricate and Core XY, which is part of the motion system that I use here, the name of the motion system. Motion system as in like the belts here. Someone at MIT developed it and they called it Core XY. I don't know why, but I incorporated it into the name. So let's go through some of the things that I've added into this. I have a smart LCD screen down here that takes an SD card with a file on it, a 3D file, and I can go through and disable the steppers. I can home the extruder. I can do a bunch of presets here. I can also control the temperature and the different aspects of the motion, like the acceleration and the speed and a few other things. And the main screen tells me the percent speed that I'm running at, so I can go faster or slower. This is the amount of time that's elapsed. This tells me where the hot end is, and that tells me what the extruder temperature is. And I control it with this knob here. The most important part is the hot end up here. Let me take this off. All the panels on the side have magnets, so I can remove them. The hot end right here it becomes very hot. Right, it's currently at 210 degrees Celsius. It has a fan that runs right here that cools the aluminum heat break so that all the plastic parts up here don't melt. There's a heating cartridge there and a thermistor, so I know exactly what temperature it is. This tube right here has plastic filament that comes from this spool here. The plastic goes up through this stepper motor that acts as an extruder that forces it through this white tubing all the way through here and then forces it down into the hot end. That's kind of what controls the feed rate of the plastic. Coming over farther, we have these two things. These are called end stops, and this is a mechanical one, and this is a Hall effect one. As you can see, when I close it, I get close, the flag kind of goes in front and the light turns off. At that point, that would stop. On this one, it comes in and hits the stopper, and it zeroes it, so that the machine knows that this position right here is 0. And then this is the X direction, this is the Y direction, and it can go from there. This little guy over here is called a capacitive proximity sensor. And what it does is it triggers, it trips the switch anytime it gets close to a certain object. So if I put my finger in here, you can see the light over here turn on. So I use that to measure the distance off of this mirror here, which is the build plate. The build plate can move up and down based on these screws right here. Those are called lead screws, and they're run by the stepper motors down here. Those work in sequence so that the bed stays level, but I can never get it perfectly level. So what happens is this proximity sensor measures 5 points throughout the bed, like one here, 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 and here, and creates a plane within the software through those points. Now the software knows that it knows how to correct the position, the height of the bed based on that plane, so that this hot end here is always interacting with the same plane. So for example, if this corner is lower, if the hot end moves that way, the stepper motors and the lead screws will raise the bed up a little bit so that it stays at a constant distance from the bed. Let's see, I printed these handles to help move around for the Maker Faire a few days ago. And cool thing is, this is the aluminum extrusions. They're called V-slot extrusions. And the cool thing is, they're the frame. So there's a cube here made of this stuff, but it's also the linear bearings, the linear rails. So it's the frame, but also the trolley kind of slides along it as well. I thought that was kind of cool. Let's see what other stuff we have. Down here is the power supply. That's a 20 amp power supply that plugs into the wall. I know the wiring's a little shoddy, but it works. Down here is the brains of it all. It has a little fan to keep it cool. I'll take that off so you can see it. Let's see. So that is an Arduino board with a specific ramps 1.4 shield that goes on the top. And that controls everything between from the heat of the nozzle to the stepper motors to the position of the hot end, and everything comes from that. For some reason, the 3.3 volt supply on that board isn't working, so I'm down converting at 12 volts, or I think it's 5 volts that's missing. So I'm down converting the 12 volts through this converter and inputting it through the printer cable port to supply the 5 amps. So I need to fix that eventually, but it works now. This little guy, which you can kind of hardly see, is something I recently added. That's the Z Max mechanical end stop. I've just recently tried to put it into the software so that when the print is finished, regardless of how high it is, the bed moves all the way down and then hits that end stop, and it'll shut everything off. That way, when I have a door in here, I can open it up, and I can just open up the door, take the part out, and it's right there in front of me. Well, I'm going to try to start a print now and see how it goes. So I'll go here, hit print from SD. There's a bunch of different files on here, but I want to build this guy. It's a part that I just made. It's a door joint, part of a door joint for this future door that goes right here. I figured I might as well 3D print the joint as opposed to buy one. So as you can see, the temperature is going up. It's now reached just over 210, which is the target, and it's going to come back down. Now you can see this is starting to home, and now it's about to go and find those points. Here, I'll see you. You see the light turn on, and then it picks another point. Alright, so now it's finished homing and it's going to start the print. So let's see how well this works. So you can see it's just starting. Alright, now the plastic is starting to come out. It's a little bit hard to see from the mirror, but alright, that seems to be working well. Now, I mentioned how the bed changes the height depending on where it is. Look at the lead screw right here. So as it's moving, it's making these fine adjustments depending on where the head is to try to keep the plane level. And here it is, it's printing, and you can see that line. And I'll turn it back on in a little bit to show you progress. Something else to mention, that these two motors here are the only two motors that make this move in the normal Cartesian plane, and it runs on these belts here. These parts, all these plastic parts, are custom made on the first 3D printer that I have, the Robo 3D, and some of the main components in here, like the pulleys, I purchased from a store, but everything else here is 3D printed. Also, this little bracket here, this one and this one, they're specifically made to be able to easily pull off. I just take two screws out and I can put a new bracket on depending on the purpose that I want. So if I wanted to reprint that, I wouldn't have to disassemble the whole chassis. I could just pull that off, reprint it, and add it. I'm gonna have to do that because this blower down here I made way too big, and it's actually makes cold spots on the heated bed. So I need to make that one smaller and reprint the bracket so it can fit. Anyway, I'll show you the progress in a little bit. So while the print is going, I wanted to show you the kind of the basic process of creating a model to bring it to the printer. So this is a model that I've kind of mocked up to create this door and this plexiglass here. And so this will be the door, this is the full plexiglass with both these two together. This would be the handle, and these are the 3D printed joints that I'm planning on making. So what I would do is, after I model it and kind of fit check everything, what I would do is I'd go and turn off a bunch of these items down over here. Well, let's keep that one. That off, that off, that off, that off. Okay. So that this guy's left, and it's just a simple part. I have screws and hardware that I made these holes to fit, so that I already have the hardware to screw it all together. So then I'd go and I'd save as a .stl file, and then what I'd do is go into this software called Cura, which is free software, free slicer software that a company called Ultimaker makes. They have really good quality printers. And so this is the part that I've already put on there. I can rotate it. I can, rotate it any which way I want. I can copy it and make more than one. I can slice it in half. And the cool thing is, I can go into here and go to layers, and it generates essentially what the machine sees. I'll give it a minute. So I can go all the way down to the first layer, so you can see that. And then as I increase, you can see all the different tool paths. You can see the interior, which is I've set to 20% density, so it creates this thatch network, a pattern. And then you can see the hole being generated right here, the sideways hole, and then you can see it get the solid layers at the top. And I usually always check that just to make sure everything's going to go right. Over here I have different settings, so I can do layer height, shell thicknesses, which is how many outer layers there are, the fill density, which I said is 20%, the print speed, the temperature that I want, and then down here I can put in supports. The software automatically generates supports. So if I have an overhang, like for example, if I was trying to do this, print it like this for some reason. So this is right here as an overhang, and you can't print material over empty space. So what would happen is, if I set supports here, touching build plate, it would rerun, and it won't show in this view, but if I go back down to layers, you can see all the support material that's been added there. So that's what happens automatically, and the software knows to do that. That way, when it comes out of the printer, you can just break the support off, and then you have your part. But then after that, I just hit Save Toolpath, and when I have an SD card loaded, it can save directly to the SD card. And then I just take it out of my computer and add it into the slot over here. And then I can just start the printer, that part, directly from the printer. There's no printer cable, it runs on its own. Benefit of that is if the computer crashes or freezes, the printer doesn't freeze. So I just wanted to show you some of the process that the parts go through. So the part is done, and all I have to do is just reach in and pop it off, and you can see some of the quality here. There's still a little bit to improve on, but all in all, it looks pretty good. Something to check is if the diameter of holes are actually the right way, the right diameter, and if the outside dimensions of this part are actually correct. You can always account for that in the design of the part, but I'd like to have it as close as possible.